Hey, my name is Jonathan Elm, and in this video, I'm going to show you how to test the significance of a correlation using R. So I'm going to use the salary dataset, which I have here on the desktop. So the first thing I'll do is I'll go ahead and read the data into R. So I'm going to right-click the file. I'll do get info. I'm going to copy the path. Data equals read.csv. In quotes, I'll put the path. And then I'm going to add the name of the file. Okay, I'll make this script a little bit wider so you can see it. Alright, and then I'll go ahead and I'll run the script. Remember, it's always a really good idea to take a look at the first 6 rows of the data set just to make sure you read the data incorrectly. So we can use the head function to take a look at the first 6 rows. And if I take a look at variables here, I can compare them against the values that I have in my data set. Looks like salary is 83,404. Number of pubs is 3 and 19. 83,404, 3 and 19, right? So it looks like I've read the data incorrectly. So let's say I want to calculate a correlation. So one thing that we can do to calculate a correlation is to use the core function. And so if we're going to use the core function, we need to give R the variables that we like to calculate the correlation between. So if I wanted to calculate the correlation between salary and number of pubs, I can do data and then in square brackets salary and number of pubs. So remember that data, right, is an object in R that contains our data set. Right? That's what we see here. It contains these variables and each of these observations for those variables. And we can use square brackets to subset some of the variables or some of the rows. In this particular case, right, we have inside the square brackets, we have a comma. Okay, so what goes before the comma indicates the rows, and what goes after the comma indicates the columns. Since we left a blank space or we didn't put anything before this comma, it indicates to R that we would like all of the rows. Okay, so by including inside this C function, which creates a vector, we have salary and number of pubs. What this is going to tell R is we want to extract the variable salary and the variable number of pubs, those two columns, and then all of the rows. So when we put this whole thing inside the core function, we're asking R to calculate the correlation between those two variables. So if I highlight and run the code, you can see that I'm getting a 2x2 matrix as output. Okay, so of course the correlation of salary with itself, right here, that's equal to 1, right? So the correlation of any variable with itself is equal to 1. The correlation of number of publications with itself, of course, that's equal to 1 as well. And in the off diagonal, we have 0.3553388, and that is the correlation between salary and number of pubs. Okay. And of course, this is the same value on the upper side. So this is the correlation between salary and number of pubs as well. We have the same value. Okay, so it's simple enough to calculate correlations. Typically, or often, we also want to test the significance of the correlation. I'd like to test whether or not that value is significantly different from 0. And to do this, we'll use almost the same process, but instead of using the core function, we'll use the cor.test function. And so cor.test is a different function which will calculate the correlation between two variables, but it will also give us output that will indicate whether or not the correlation is significantly different from 0. So if I highlight and run this, sorry, I have to use a slightly different format. Maybe we should back up to kind of review this a little bit. So I got an error, right? So this is saying argument y is missing. And actually what the CoreTest function is expecting is two different variables. So if I highlight and run the core function up here, right, we know that we'll produce the correlation of 0.3553. Well, there's another way to use the core function. So I'm going to copy this code and I'll paste it here. And what I'll do is I will enter two different variables, right? So I have data $salary and then data $number of pubs. So now what we're doing is we're putting two variables as input. And this should give us the same correlation. Really the only difference between the code in these two situations is that in this situation up here, I'm putting in kind of like a matrix or a data frame that has two columns and multiple rows. And in this situation, I'm putting in one variable and then separately putting in a second variable. So if I highlight and run that, then I get the correlation of 0.355338, right, which is the same number as the one above. Okay. And then the CoreTest function by default will only take these values. So I'm looking at the variable salary in the data set called data and the variable number of pubs in the data set called data. So if I highlight and I run this code, if I take a look at the output, it's going to calculate the correlation for us. Okay, so we see the sample estimate down here of the correlation. This is the same as the one that we got from the core function using either input forms for data sets. But you'll also see that we're getting a p-value here. Right? And so this p-value, I'm just going to copy and paste it here. So we have the output. This p-value is if the null hypothesis is true, right, which in this case is if the correlation in the population equals 0, then the probability of getting this correlation, well, I should say of getting this sample correlation, which was equal to, let's say it's about 0.355. So the probability of getting that correlation or a value more extreme, that means a correlation that's greater than 0.355 or a correlation that's less than negative 0.355, right? Because more extreme means it can be greater than the value or less than its opposite. Okay, so larger than 0.355 or less than negative 0.355. This is going to equal the p-value, the 0.00028. So what we do is, for a moment, we assume that the null hypothesis is true, right? So the null hypothesis in this case is that the correlation equals 0 in the population. If that assumption really is true, then what we can do is we can calculate a probability of getting our correlation or a value more extreme. Okay, and so the probability of getting that correlation or something more extreme is really small. And typically we say that if the the p-value is less than 0.05, it's common practice to reject that null and conclude that the correlation is significantly different from 0. So in this case, we'll go ahead and we'll conclude that the correlation is significantly different from 0 because this p-value is less than 0.05. Okay. So really the example today was just to demonstrate the CoreTest function. So I think in another video we learned that we can use the core function just to calculate raw correlations. So if you're just looking to estimate the correlation for the sample of a couple of variables, you can use the core function. If you want to go one step further and get some output about the significance of that correlation, then you can use the cor.test function. And as we learned just in today's video, this one you'll need to use the data $ operator when you're subsetting variables, whereas in the core function above, you can use either square brackets or the $ operator. Okay. Thanks so much for watching the video. Please like it if you liked it, and let me know if you have any other comments or questions, and otherwise stay tuned for more videos.